Find the most general form of the antiderivative for the following indefinite integral. So here we need to begin by rewriting the integrand. And there's several ways to approach this problem. The beauty and curse of algebra is there's often more than one way to get to the same answer. So here is one such way. So I'm given, I have secant of 5 theta in the numerator, and this is all divided by cosine of 5 theta minus secant of 5 theta. So because we have two terms, we have the difference of two terms in the denominator here, we can't separate those. We can't separate our denominator. So instead, what I'm going to do is think about how can I rewrite secant of 5 theta. So the numerator stays as it is. This is still secant of 5 theta, and this is now all divided by cosine of 5 theta, and I'm going to rewrite secant of 5 theta as 1 over cosine of 5 theta. And then just worrying about our denominator here, I'm going to get a common denominator in the denominator. So I'll think about cosine of 5 theta being written as cosine of 5 theta over 1, and we'll multiply the numerator and denominator here by cosine of 5 theta. And so we can rewrite this as secant of 5 theta all divided by cosine of 5 theta squared minus 1 all over cosine of 5 theta. So we now know fractions in the denominator will flip. So I can rewrite this as secant of 5 theta multiplied by cosine of 5 theta all divided by cosine squared of 5 theta minus 1. And we have some really nice simplification now. So we know that this secant in the front from that numerator can be rewritten as 1 over cosine. So I have 1 divided by cosine of 5 theta multiplied by cosine of 5 theta all over cosine of 5 theta squared minus 1. So the cosine in the numerator and denominator cancel each other out. And then in the denominator, we recognize that this is a Pythagorean identity. So let's quickly recall from Pythagorean's identities that we know that sine squared of k theta plus cosine squared of k theta is equal to 1. So we can rewrite this, or this is equivalent to cosine squared of k theta minus 1 is equal to minus sine of k theta squared, which matches what we have above. So we'll use this Pythagorean identity to rewrite our integrand one last time. So when we were left here, we had 1 over cosine squared of 5 theta minus 1, which is equal to 1 over minus sine squared of 5 theta, which is equal to negative cosecant squared of 5 theta. And this is a general antiderivative. We recall that if we have the integral of cosecant squared of some constant k theta d theta, that this integrates to minus cotangent of k theta divided by k plus an arbitrary constant c. And so we're ready now to antidifferentiate. So we have minus the integral of cosecant squared of 5 theta d theta. So this becomes minus a minus cotangent of 5 theta, all divided by 5, plus some arbitrary constant c. And we see negative times a negative will produce a positive value, leaving us with a beautiful final answer of 1/5 multiplied by cotangent of 5 theta plus c.